Hello, and welcome to our Spring 2025 Data Science Clinic project titled College Financial Health. Our team, Disha, Danny, Jeanette, and Jerry, collaborated with the Data Science Institute, guided by our internal mentor Alex and our TA Polly. Here's an outline of today's presentation. First, let's discuss the project overview and the project problem. Colleges and universities across the U.S. are facing a financial reckoning. Federal grants are drying up, enrollment is falling, and even elite institutions are struggling with aging investments. For smaller schools, the impact is sharper. Shrinking student bodies lead to dorm closures, job cuts, and economic strain in entire college towns. These financial pressures don't just affect institutions. They directly impact students and families, making one of the biggest investments of their lives. So broadly, colleges nationwide are facing growing financial pressures that often remain unclear to prospective students and their families. For students investing thousands in college, tools that assess institutional financial health are essential to understanding the value of their education. And currently, the Integrated Postsecondary Education Data System, or IPEDS, is a primary data source for students and families. However, the data is vast, messy, and difficult for non-experts to interpret. That's where our project comes in. We're building an interactive dashboard that makes complex financial data accessible to students and families, supporting informed decisions based not just on prestige, but also on long-term institutional stability. Before building, we reviewed existing tools and explored how we could improve on them. So let's look at an existing attempt to address this problem. This tool is the Financial Fitness Tracker, which helps users view financial health metrics like net price, tuition trends, and enrollment. However, it has key limitations. It's not interactive, as users can't engage with or filter the data dynamically. It also lacks deeper explanations for what the numbers mean, and it leaves out several critical metrics, particularly around institutional aid, endowment health, and operating margins. So next, we'll introduce our goals for addressing these gaps in our improved dashboard. Here are the three key core goals of our project. 1. Make complex data understandable. We aim to translate the complex IPEDS data into a user-friendly dashboard that offers both interpretability and interactivity. 2. Identify financially at-risk institutions. We'll track key financial indicators over a 10-year period, and we'll introduce these metrics in our data and methodology section later. 3. Enable better college decision-making. This project supports transparency and empowers students to make informed, financially grounded college decisions. Next, we'll discuss the data used for the project and the associated methodologies that enabled us to make these goals a reality. So broadly, our data methodology was outlined in the following steps. First, we identified the data sources necessary for the project. Second, we processed the raw data, merging multiple datasets into unified files suitable for exploration. Third, we validated the data to ensure that it was internally consistent and aligned with our expectations. During this stage, we also identified issues that informed our data cleaning strategy. Finally, based on insights from validation, we refined our processing logic through several iterations, adjusting, revalidating, and cleaning until we reached a satisfactory level of data quality. We use IPEDS data, which is reported annually and split across multiple datasets. Each dataset focuses on specific aspects of a school, such as student aid or admission statistics. We downloaded the most recent 10 years of data. For our dashboard, we chose to use the following datasets: fall enrollment, instructional staff salaries, and financial reports. These data sources capture the following metrics: enrollment trends, tuition revenue per student, endowment levels, operating margins, faculty and staff expenses, and institutional aid. For the purpose of benchmarking, we also obtained the latest school classification data from the Carnegie Commission on Higher Education. We chose to use their basic classification, which groups schools based on the types of degrees they grant and their fields of study. After downloading the raw data, we ran it through a processing script that consolidated and cleaned the data across all available years. Using the Carnegie classifications, we then grouped schools to calculate benchmark values for each classification. Before we could incorporate the data into our dashboards, we first needed to validate it to ensure its quality and reliability. This data validation process was conducted using computational notebooks and focused on two key areas: understanding missing data and assessing the consistency of the existing data based on domain knowledge. For missing data, we asked several guiding questions. How many rows contain missing values? Was the missingness random, or did it follow a pattern that we could detect? Based on these findings, should we impute the missing values or remove these rows entirely? We also check for alignment with real-world expectations through sanity checks based on background research. For example, since endowment values represent monetary amounts, we needed to ensure that these figures were always non-negative. We decided to flag missing and poorly contextualized data directly in the dashboard, since our focus was on visualization rather than analysis. We also recognize that missing data can be itself meaningful. For example, a lack of financial disclosures may indicate limited resources or low reporting transparency, both relevant to prospective students. To add context where data was incomplete, we included benchmark lines based on each school's Carnegie classification, enabling pure comparisons. Finally, we built in logic to flag values outside expected ranges, such as negative endowment figures or unusually high tuition, to ensure the data was both complete and reasonable.
We will now discuss our deliverable for this project, our Streamlit dashboard. For our dashboard, we have chosen to use Streamlit, a tool that allows us to build full-featured web applications using just one coding language, Python. Streamlit helps take care of much of the website creation and user interface, meaning that our team could focus its attention on creating our desired visualizations for the users. Streamlit also allows for rapid prototyping, meaning that we can make changes to our code and see those changes reflected on our website in real time. We will now do a quick walkthrough of our dashboard to further understand how our website helps users obtain the necessary information to make grounded decisions for their educational future. We start by opening our dashboard, and we immediately see a search bar. We do not see any visualizations yet as we have not selected an institution. Let's search for UChicago. As we begin typing, we see our search bar begins to narrow down the potential institutions we are looking for based on the search query. We select our institution and see that a number of visualizations appear. Each visualization corresponds to a particular metric and has a short description of what the metric measures and how to interpret it in terms of an institution's financial health. Most of our visualizations are line graphs, as the goal is to not only understand a school's current financial status, but also observe their trends over time. We can see that unlike the existing tracker, our dashboard not only has more visualizations and metrics, but allows you to interact with the visualizations, as you can zoom in and out or hover over specific data points to obtain exact measurements. Our dashboard also includes a benchmark to compare to other schools that are categorized under the same Carnegie classification, and notices the user when data might be incomplete for a given metric or institution. We also see unique visualizations like maps and bar graphs for enrollment data, which also allow for interactivity, as users can hover over states to better understand an institution's demographics. In essence, our dashboard presents a more user-friendly, modern alternative to the existing tracker. We will now discuss the main results and contributions from our project. Throughout this project, we accomplished two key tasks. First, we processed and validated data from IPEDS and the U.S. Department of Education to ensure its accuracy and reliability. Then, we used the clean data to build an intuitive, interactive dashboard designed as a modern, clearer alternative to the original tuition tracker. The dashboard delivers two core benefits. It improves transparency around college financial health, helping prospective students make more informed decisions. It also simplifies large, complex datasets into clear visualizations, making key metrics easier to interpret at a glance. Looking ahead, we hope to expand the scope and impact of this project. First, we plan to include a broader set of financial metrics to deepen our analysis. Second, we aim to cross-validate our data with other sources to ensure precision and strengthen reliability. Finally, we'd like to add more interactive features and develop an overall financial health metric that combines all of our metrics, thus helping users compare an institution's financial health against other institutions. Lastly, we'd like to thank our internal mentor, Alex, and our TA, Polly, for their support and guidance throughout the project. That concludes our presentation. Thank you for your time.